first up is logic. So another name when we talk about logic, we also talk about these Boolean operations or Boolean operators. This just refers to true false, and a Boolean object is basically something that's true or false. So we have the basic Boolean operators are or, and not. So or is, for example, if the statement is x or y, then the result will be it will evaluate if x is true or false, and then it will then evaluate y if x is false, and then effectively it's saying if one of these two is true, the statement is true. Only one of them needs to be true. And this is on the right here is just sort of how it's evaluated internally. Because the computer doesn't have to necessarily evaluate all the expressions to determine if that statement, that operation is true or false. So an and would be if both x and y are true, then the and statement would be true. And not x would be the opposite of x. So if x is true, then not x is false, and vice versa. We'll see some examples of those. Maybe even more commonly seen are comparisons. So these are cases where you're doing a comparison between usually two objects, and there's some priority that's assigned to them that we can get into. But for the basic meaning, there's less than, which is you're familiar with from math, or less than or equal to. These are used in referring to numbers. Greater than or greater than or equal to. Two equal signs is equal. That's a comparison saying are these two things equal. And then an exclamation mark with an equal sign is not equal. And then there's something called is or is not. You would think that this would be the same as equal or not equal, but in Python, objects can have value, but they also have this identity. So if you have, I think a good way to illustrate this is if you have and I apologize to the YouTubers. I'm going to use the board here for a minute. So. But you guys are my first priority. So. Okay, so we have these two objects in Python. One is the integer 1, and the other one is this floating point value 1.0. We can set the variable a to 1, and we can set the variable b, we can assign that as 1, and then we can set the variable c as 1.0. If we said is a equal to c, that would be true, because 1 is equal to 1. But if we said is a is c, it would be false, because this is an integer and this is a floating point value. So I guess this idea of equivalency versus identity, and we'll see that in a minute. So let's do some examples here. So so in this first example, we have two expressions in parentheses. So these are going to be evaluated first, and only if they're both true will the statement be true. So in this case on the right, this is bad form, but you can do it. Basically, the addition will be done before the comparison. So 2 is equivalent to 2. And similarly, B is equivalent to A plus B, because remember that when there are strings, they're being concatenated, not added to each other. Yeah.
Parentheses necessary here?
Well, we can try. I mean, for my eye, boy, I don't even know what this is doing. I mean, we can, yeah, I think it's doing the same thing, but it's really hard for me to. I'd rather not leave it up to sort of whatever, however the order of operations are done. I don't think I have anything in here about that level of. Yeah, I'd have to look it up exactly which one is done first, the and or the equivalence. I think it's I think you're probably right. I think it probably can be done without it. This is kind of a weird example because we're pushing the system quite a bit. Next up, we have a statement where both of these things are, well, one of them is true and the other one is false. So 5 is greater than 4, that's true. But 2 is not less than 1, so that's false. But we say, so here we're saying true or false. Well, true or false is true. One of those is true. Here we're saying this string is this string, so that's true. But if we say, this is the example I just showed you on the board, so an integer is a floating point value, it's false. Even though they're equivalent, meaning the mathematical value is the same, this is more referring to the object that is represented. And the object here is an integer object that has the value 5, and the object here is a floating point object that has the value 5. And then we can use the not equal operator. So is 5 not equal to 5.0? False. They are equal. Okay, so that's the order of operations. You can, I believe this is these parentheses are optional, but it's up to you how you deal with that. I prefer to be more explicit about it. I find it easier to read the code. Yeah. So you can run it if you're chaining operations. You might all of a sudden change the behavior if you add it. Basically, if you type something that. So yeah, if you type something that then supersedes the operations you already have, then that can. The parentheses are always going to be sort of honored first. Okay, let's see if we can. It should be less than, right?
Yeah.
Oh, right. Yeah, so what's happening here is first it's evaluating this one. So and then basically when you do a comparison like this, it's evaluating false as 0. I think we'll get into this later, but it's a little strange how it evaluates the true false as numbers. But regardless, it does have, they do have values that we'll see. So moving on to loops. In this case, we're using, we tend to be using logical evaluations in loops that allow us to work through blocks of text. So with an if statement, we have this basic structure where the first thing we're going to do is ask if a statement is true. So we can call this test one. This would be, say, if x is greater than 5, then do this. And you know, you have some value of x and you don't know if it's greater than 5, but if it is, then you'll do this first statement. Now there's an optional, there's two optional things you can add. You can just have an if statement, say if this is true, do this. And then if not, it won't do it, and you move on with your code. But you might want a couple other ways to modify this. You can have an else if, which in Python is called elif or elif. What this is going to do is going to say after the if statement. So if this is true, do this. But if not, then if this other statement is true, then I'm going to do this next block. And you can do this. Where did I go? You can do this. Okay. You can do this multiple times, and keep doing this. And then finally, if you, again, this is optional, you can have an else statement at the end, which is if nothing else above is true, then execute this last block. So those are if tests. It's not really a loop. It only goes through once, but it's very similar to a loop in the fact that you're only executing some code if you meet some condition. A while loop is where you have a test, and while this thing is true, while this test evaluates as true, you're going to do these statements. And it also has an optional else statement, which can be run if there's no break in the while loop when it's all done. You can also, within the while loop, there's ways to break out of a loop. So you can say, while this thing is true, do these statements, and then if while doing that loop you meet some other test, break out of the loop and skip to the end, which would be down here. And there's another statement called continue, which doesn't break out of the loop, but it continues right back to the top of the loop. It doesn't execute the rest of whatever might be below here. And then again, you have this optional else statement, which would be run if we didn't hit a break in here. But the most common form of a while loop is just the while statement and the test, and then some stuff after that. These are just other options that you can use. And there's one other statement that, and I apologize that my font is so big that it's showing up a little strange here, but we have this pass statement, which doesn't do anything at all. It's just a placeholder when you're building your loop and you want to test it. Finally, there are for loops, which will work kind of like a while loop, except for instead of waiting for some statement to not be true anymore, it's just going through every element in an object, such as a list or a dictionary or a pandas column from a data frame or something like that. So you can say for some variable in this object that I'm going to iterate through, do something every time. And then again, you have this optional else statement, but we don't typically use that very often. And again, we have these break and continue options and that we can use. this will be more clear. This is all kind of abstract now, but we'll see some examples here. So first we'll do a for loop, and this loop contains if, else if, or elif, and else statements, as well as print statements, and there's even a break here. So what we're going to do is we're going to say for I in range 5, so this is, if I should show you range 5, so this is this is actually doesn't show me the values, but basically this is going to give me a list from 0 to 4, not including 5. So for I in this range from 0 up to 4, if I is in the list 1 or 2, so if I is 1 or 2, it's going to print it's 1 or 2. And then else, if I is in 3 or 4, it's going to say it's 3 or 4, else it'll say print must be 0. So what's happening here is, in fact, I can add this. This just prints the value of I. So you can see this would be a nice thing to do if you're debugging your code and you want to make sure you know what's going on, even though you're not actually using that. So it's saying for I in range 5, I could have changed this to, I could have said, I could comment that out and say 0, 1, 2, 3, 4, and it'll give me the same. That's basically the same thing it's doing. But I'll leave it as is. So it's gonna print I, and then if I is in this list, it's going to print it's 1 or 2. So first we started with 0. So is 0 in the list 1 or 2? No. So we go on to the next statement. Is else if 0 is in 3 or 4? Well, no. So we're going to go on to the next statement. So else, it's going to say, well, it must be 0. And next we go to 1. We're going to print 1 and then say, is 1 in the list 1 or 2? Yes. So we're going to print it's 1 or 2, and then done, because these else statements don't apply. We satisfied this first criterion. Same thing for 2, and then for 3 and 4, it's going to evaluate false here. So then it's going to go on to the second statement, else if, say, 3 is in this list 3 or 4, yes, so it's going to print 3 or 4. Then here's a while loop. So we can set j as 0 and then say while j is less than 5, we're going to print j, and then we're going to add 1 to j. So this is some special notation. Instead of saying, this is effectively j equals j plus 1. But in computer science, we do this a lot, so we don't want to have to type this every time, so we can use this notation plus equals. So saying j plus equals 1 is the same as saying j equals j plus 1. I'll leave this part out for now. It's an optional break statement, and then if these criteria is not met, then it will print this else statement, and then it's done. Okay, so what we're doing here is we're saying j is set to 0. That's just the initial condition. And then while j is less than 5, so it's first going to say, is j less than 5? So j is 0, so yes, it's less than 5. Okay, so it's going to print j. It's then going to add 1 to j, and then it's going to go back to the statement here. And now j is 1. So is 1 less than 5? Yes, so it's going to print 1, add 1, now it's 2. Is 2 less than 5? Yes, so it's going to print, add 1, so now it's 3. Is 3 less than 5? Yes. It's going to print 3, add 1, now it's 4. Is 4 less than 5? Yes. Print 4, add 1, now it's 5. Is 5 less than 5? No. So it'll exit the while loop, and if there's this else statement, it'll execute that, so it'll print all done. Oftentimes we don't have this else statement. It just finishes. Now, if we wanted to test out this break statement, let's say if j is 4, we want to break, then we don't get that last value. So because remember, we're printing and then adding 1. So we printed 3, we added 1 to it, now it's 4. I say, now if j is 4, I don't want to do this actually, so I'm going to break. Now this is an example that you don't need to do that for this particular example, but there are cases where you might want to break out of a loop. Any questions on the loops?